kind introduction. It's really a pleasure to be here. It's a beautiful campus. I feel like I'm just starting to see the lay of the land here. But I'm looking forward to chatting with an awful lot of you during the course of the day today, and I appreciate your coming over to see me this morning. So today I'm going to talk a little bit about my background and kind of walk through how I got to be here in front of you today. That's all in the resume, but I figured I'd hit the highlights just in case anybody hadn't looked at that yet. I'm going to go through my research agenda a little bit because I think it covers both the science and the policy and the law side of it. So I think it's helpful to talk about the broad array of things that I do like to work on or I'm interested in working on. Then we're going to dive into the steelhead distinct population segments. That's the gorgeous fish we've got here. The discussion of how do we protect this species under the Endangered Species Act, and more broadly, how do we figure out what we list under the Endangered Species Act. And then at the end, if we have time, I'll talk a little bit about how I think I would fit into this position. That can be more of an organic conversation. It seems like this position is still evolving as we talk right now. So I'm happy to talk about what I think my strengths are in terms of what this program looks to be doing right now. And if we have time, we'll kind of go through that. So as I said, and as you said, I attended the University of Kansas for my undergraduate work. From Lawrence, Kansas originally, Midwestern boy, born and raised. Finished there in 2002, got a BS in biology and a BA in environmental policy. I think like a lot of people, I realized that I was maybe 3 classes away from the environmental policy degree because I've been taking classes I was really interested in all along, and then all of a sudden found out, hey, there's a major that puts all these things together, and so kind of stepped into that. I was supposed to graduate in 2001, and then realized in 2001 that I was really close to this other degree, and it looked really interesting, and so that's why I took the victory lap and picked up the environmental policy degree. It's nicer than an extra year, right? Super senior. So my wife and I met at KU, we got married then, and we went to DC together. So we left Lawrence in 2002, moved to DC. She started teaching at a high school there, the field school, and I went to work for the US Department of Transportation. I hadn't done any transportation work before that. I was a Truman Scholar and they had a Truman Fellowship there, and so I could step into a position there right away and didn't take up one of their FTEs, and they could pay me out of grant money, so they were happy to do it, and I was happy to be there. And there really was a great environmental angle there. So I was on the climate change core staff and actually chaired that for the department, which was the group that oversaw all the climate research within the Department of Transportation. We had about roughly a $3 million budget, so not a big pot of research money, but there was some interesting work that went on there. And then represented Department of Transportation more broadly within the administrative efforts on climate change. If you look at the timing there, that's during the first Bush administration, which is really an interesting time to be doing climate work in DC. And it was a good political education as far as how you shape the discussion around climate change in order to get different people with different backgrounds on board with doing that research. So a great education for somebody fresh out of undergrad. We did a lot of hydrogen fuel cell work, and then I was on the team that wrote the new fuel economy regulations. So that was a nice kind of exercise in actual rule writing. And kind of a good exposure to administrative law early on. Really enjoyed my time there, but knew I kind of always wanted to go back to school. Originally it was just a PhD, and then at some point I decided I need to get the law degree too. So I started looking around then for schools where you could do kind of a joint degree between the law and the PhD work. Not a lot of places were super excited about doing that, and then within that group of places that were kind of willing to consider it, there weren't a lot of people who did the kind of fish work that I'm interested in. But I found UC Davis and a great advisor there who does fish genetics and fish population genetics, and so that's what I wanted to do. And he was really excited about doing a joint degree, and Stanford had no problem with it. I think they were really kind of excited about finding a way to bridge that gap too. They were big on interdisciplinary work there. So I started at UC Davis in 2005, did a year there, and then went down to the law school for 3 years, and then back up to UC Davis to finish the PhD. The one thing I want to call out from law school, it's a great experience, super intense, as law school tends to be. But I spent my last two years there working in the environmental law clinic. And I'm not sure how familiar people are with this idea of what a law clinic is. But under the California rules, and most states have similar rules, starting your second year of law school, you're actually allowed to go out and practice law when you're still a student. And so you have to have a professor overseeing the work that you do, but you have clients that you represent, you meet with those clients, you can go to court, you can argue in court, you can file things on behalf of your client in court, just like a real lawyer. So it's tremendously exciting, it's terrifying. You learn really quickly that the things we talk about in class actually matter. And when your homework is getting ready for a court hearing, you tend to really do that homework. Because you stand up in front of the judge and you don't know what's going on, it's terrifying. My mom was a judge growing up and she terrified me at home, so it was even worse when it's not your mom. But I think it was far and away the best thing that I did in law school, because it gave me a feel for what it's actually like to be a lawyer. And it gave me a feel for what we're trying to do here. Why are you in law school, right? And that kind of exposure that makes the education much more real was my first kind of serious exposure, I think, to that experiential learning, and it made me a believer from day one. When you're doing this work with a goal in mind, and when you can start to see that goal, kind of taste what it's going to be like, it makes it much easier to go through the rest of law school. It makes it much easier to go out and really see how your classes apply. And you bring something back to those classes when you have some actual experience, as opposed to being kind of a blank slate. So that was, I think, one of the highlights for me in law school. And I had a similar experience with the PhD program. Actually took a class that was ecogeomorphology, where you go out and the class has ecologists and geologists and policy folks. You all study a river together, and then you go out and you float that river after you've studied the river, and you actually get to see how the things that you've studied, things you've learned in the class, play out on the ground. And again, it's this idea of experiential learning. What does a river look like when it's managed? What does that do to the fish populations, to the water levels, to the sandbars, to the plants in the rivers, to the insects in the rivers? And it makes it real, right? It makes you understand how that material you're studying, how all these theories actually look in the wild. And so both these things together made me a real believer in experiential learning, and that's something I try and bring to my classes when I teach, and something I think is really important, especially in a program like environmental studies. So I went on and finished the PhD at UC Davis in 2011. From there, started looking for a clerkship. You can kind of think of a clerkship as a postdoc for lawyers. It's a chance to go out and work with a judge who's actually making decisions. And so I got a clerkship with Judge Briscoe on the 10th Circuit in Kansas. The 10th Circuit is a circuit court of appeal. And if you think about our legal system, there's federal district courts, and then there's the courts of appeal and the Supreme Court. So it's one step down from the Supreme Court, one step up from the trial courts, and it handles all kinds of appeals. So I did some environmental law there, I did immigration, drug stuff, all kinds of different cases. It's a great legal education. And then from there, I did a clerkship with a district court judge. I'm actually still, right now, finishing a clerkship with a bankruptcy court judge. And that's an 80% position. And so with the 20% I had off, I started teaching at KU, and that's how I got into the environmental law class last summer, then the environmental law class I taught last spring. So that's kind of a quick run through of my background, probably more details than people want to have. But that's how I got to be here. Through all that teaching and all that, I've been teaching in one way or another since the late 90s. I taught, when I was at KU, I was a chemistry lab TA. I coached wrestling for a long time, which is a very different kind of teaching, but it's instant feedback, right? If they don't get it, they learn it really quickly. They don't get it. And I taught LSAT for 8 years for a test masters, which was a lot of fun, kind of introducing basic logic ideas to a lot of students who'd never had any exposure to kind of fundamental logic. And it also really motivated students because they're getting ready to take the LSAT, and they realize that it's kind of a big deal, and so they really come to class and they study, and it's a lot of kind of method teaching there. So a lot of fun, and I knew at that point, and with all those teaching experiences, that I want to teach. It's really important to me, and so that's a big part of why now I'm looking for an academic position. All right, so switching over to my research agenda, there's kind of 3 broad areas. I look at water, and a lot of issues around water, ecological restoration, and then agency decision making. This is administrative agencies, mostly federal administrative agencies. So one of the big things for water that I find kind of most interesting is how we restrict our water use. Restricting our use of natural resources is not something that kind of we as a society have a whole lot of experience with. If you think back kind of what we've done, we were having this conversation this morning, throughout our history, if there was a dodo left on the island and you were hungry for dodo, you ate that dodo, right? Maybe there's other islands, so you don't worry so much about it. But we haven't really had a tradition of restraining ourselves in our use of natural resources. And we have changed that, I think, in the last maybe 100 years. Part of this seems to be kind of this American problem of running out of frontier space, of realizing that frontier is core to our identity, and all of a sudden we're losing that frontier. How do we protect that? How do we maintain that? And so we're just getting started in this idea of setting things aside and protecting those things, ideally in perpetuity. I don't think we're great at it yet, but it's something that we are moving towards and something we're certainly trying to learn how to do. So we do that through public trust doctrine, through guaranteeing certain minimum in-stream flows, through state laws, state constitutions. And a lot of my research has revolved around how we do that, kind of how we've been successful and what the problems have been in terms of how that's worked. I'm also really interested in stream access. And I guess this maybe is kind of founded on this idea of experiential learning and getting people to care about something whether they didn't experience that thing. I think it's tremendously important for people to be out using their natural resources. Otherwise, why do they care, right? And so if you get people onto rivers, you get people out whitewater rafting, you get people out fishing on these rivers, it makes them more core to their identity, makes it a bigger part of the community. But in order for them to do that, there has to be access to those streams. I'm talking about just plain legal access. Are you allowed on a river or not? This is an odd thing maybe to talk to a California audience about, because in California, almost all the rivers and streams are open. If you can float a river boat down that during any season and paddle that thing down, so if it floods in the spring, then you can float a kayak down when it's flooding, then that stream is open to the public. But that's not the way it is in most states. So you go to Kansas and there are 3 public rivers in the entire state. It's a big state, right? And what, 6% of the land is public, and only 3 of the rivers are public. Colorado, which has a huge, you think of the whitewater rafting industry there, you think of the tourist industry, you think of the fishing industry there, none of their rivers are for sure open. The governor's office has been very careful to try and shun any litigation away from the courts because they don't want it to be defined as far as which rivers are open, which rivers are closed. Because if the courts went the way the courts have traditionally gone in Colorado, they would say that most of the rivers in the state are actually closed and that you could be charged with civil trespassing if you float down a river over private land. Certainly it's clear if you bump the bottom of the river with your boat when you're rafting through a stretch of water, that's a criminal trespass, and you could be charged under Colorado law. So this is a very interesting question, and states handle it very differently, right? These are little laboratories of federalism. All the states do this in different ways. And it's interesting to me to figure out why they do it the way they do it. And then even in a state like California where you have broad access, rafters and fishermen tend to restrict themselves more than the laws restrict them. And so I think there's interesting questions about how local customs play out there. All right, so restoration is the next area. I looked, for my dissertation, spent a lot of time on both conservation hatcheries and fish genetics. If we're building a hatchery to restore native fish, especially listed fish, how do we run that hatchery to have kind of the minimum genetic impact on those fish? If you take fish that have evolved in a river and then you move them into concrete runs, it's a very different environment. The fish that survive in a concrete run might not be the same fish that survive in the river. If you have fish that are really well adapted to eating fish pellets and hang out in a concrete run, those fish might do really, really poorly when you put them back in the river. You think about, these fish are constantly near in a hatchery. They're getting fed by little floating fish pellets. They're constantly looking up and sitting around near the top of the water. If you hang out in a river and you're sitting near the top of the water, you're going to get eaten really quickly. That's just a small example. But the fish that adapt to the hatcheries are not the fish necessarily that you want swimming around in your rivers. So finding ways to minimize the impacts on the fish genetics and to maintain kind of the natural wild selection, the natural selection process that's gone on for millennia while restoring these very small populations. So that's the conservation, hatchery, and fish genetics. Reintroductions on private land, also focused on this in my dissertation, and it's a question of how we encourage private landowners to reintroduce species on their land. And one of the problems with doing that, one of the reasons people have resisted having reintroductions historically is that putting endangered species onto your land, putting, for example here, the spring run Chinook salmon into the San Joaquin River locally, that affects people who use that river. Because if you continue pumping, you continue doing the things that you've always done, you may accidentally kill some of those endangered species. That's a take under the Endangered Species Act, that's a federal felony, and that's the whole world hurt, right? You don't want to go down that path. People realize it's a bad thing to do. But there are regulatory mechanisms, things that the National Marine Fisheries Service and the Fish and Wildlife Service, the agencies that administer the Endangered Species Act, have done in order to minimize the impacts, or that they could do in order to minimize the impacts on landowners, ways that they can relieve them from that liability. So I went through and looked at what they've done in the past, and then ways they might be able to do that better in order to really reduce that landowner liability and encourage landowners to allow reintroductions or even to do them themselves. I'm also interested in looking at, this is in a climate change context, finding ways to permit the reintroduction of endangered species outside of their historic habitats. So you have trees, for example, it's probably the best known example, is a tree that lives kind of in the south and where it's always lived, it won't be able to live in 50 years or in 100 years under the climate change models that we're using right now. So the question is, what do we do with these trees that are going to die out? And what people have done, and actually a lot of people have gone out and just dug up seedlings and moved those seedlings up into more northern parts of the country. This is called assisted migration, if you will, right? Trees don't migrate very well on their own, but you can move them up to an area where they'd be able to live. Marmots are another example. Marmots out here in California, little mountain rodents. They can't really move from one mountaintop to another mountaintop very easily. And so if they're on a mountaintop that's going to become drier and going to become warmer, you may want to move them farther north. But under the current interpretations of the Endangered Species Act, you can't do that. I think that's not a problem with the Act itself. I think it's a problem with the agencies have done with the Act. So I'm looking at ways to reinterpret the Act in order to permit those kinds of reintroductions. And then restoration ecology, I think we're kind of going through this in a lot of detail, so I'll skip through this a little bit. But just this kind of whole thing is finding ways to bring in kind of the cutting edge work in restoration ecology, the science, into restoration and the law. Because right now, the legal field has not done a good job of tapping into what the scientists are doing, kind of the idea of reconciliation, the idea of novel ecosystems that are going to be different than we've had in the past. Our legal system doesn't do a really good job of accommodating that yet. All right, so the last part, this is where we're going to take a little bit deeper dive. Looking at agency decision-making, ways agencies use scientific data, and then especially how courts treat agency decisions based on that scientific data, and the amount of deference they give to those agency decisions. That deference essentially means that in a lot of situations, courts say, Congress wanted the agency to be able to make this decision. This is a decision that's kind of in the area of expertise of the agency, so we're just going to let whatever the agency said stand unless it's kind of clearly wrong, right? Unless it's entirely arbitrary in case there's no internal logic to it. And so I'm looking at situations where they give deference, where they don't give deference, and then in some situations trying to evaluate really whether they should have given deference based on what we know the science to be now and how that's changed over time. Interested in integrating science into the law. When I was at Stanford, another student and I started the Journal of Law, Science, and Policy, which was a journal that really sought to do interdisciplinary work. The problem with law journals and law reviews is that the peer review, and this is going to seem really strange, but believe me, it's the way they do it. The peer review in law reviews is done by students. You're not read by your peers in the field. Right? How terrifying is that? No offense to the students, but they're the ones making the decisions about what gets published, what doesn't get published, and they're the ones who edit the articles, and they're the ones who give the final stamp of approval of the article going out. So there's no peer review in the legal academy. And it's kind of a big deal because those are, the tenure decisions get made based on what gets published, and so it becomes very difficult to, and this is, it's a huge problem within law generally, but it's what they've been doing for 80 years now, so you can imagine there's some institutional resistance to the idea of changing this. But one way that I thought we could make some inroads here was to say, look, if you're publishing something that's really interdisciplinary, you've got a lot of science in there, science does peer review. And you can't expect to publish science work, even if it's about the law, without getting peer review. And so the idea here was to start this journal and actually require real peer review of the articles in that journal. It's still going, I'm happy to say. We didn't just start it and lose it. It's still going, and they're still doing this real, interdisciplinary work. They have symposia every year, and they actually do peer review. So it's been kind of a nice little, nice victory to see, although people still think it's very strange that they have to go through a peer review process. So. The last one is what I'm going to talk about today, the ESA listing decisions for distinct population segments. So the jumping off point for this whole thing, the kind of core idea here, is that if you want to protect a species, you have to protect the variability within that species. These species are not doing well. That's why they get on the endangered species list in the first place, right? So there's something that's not working for the species. Maybe their habitat's changed, maybe the way we manage that habitat has changed. And we're going to try and change the way we interact with the species once it's been listed. But a big part of it for those species is that they need to be able to continue to adapt as well. Because we're never going to be able to restore that ecosystem to what it was historically, especially looking at something like climate change. They have to have the adaptive kind of reservoir, you can think of it, to change with the climate as the climate changes over time. So steelhead, the example we're talking about today, you want your steelhead species as a whole to have fish that are adapted to colder waters and to have fish that are adapted to warmer waters. So as climate changes, those fish that are adapted to warmer waters, those adaptations, as long as they can be inherited, can spread through other populations. Right? These fish can adapt and evolve over time in order to tolerate slightly warmer waters. And you can see that if you look at the fish in the Central Valley or in Southern California, those fish historically have been exposed to warmer waters, and they can tolerate a much higher water temperature than fish up in Northern California or all the way up. The steelhead population wraps all the way around to Russia, and so you can imagine the genetics are very different for the species up there. So if we're going to protect these species, we have to protect the full range of what we call intra-specific genetic diversity, so genetic diversity within that species. I want to pause for a second. I realize this is a really diverse audience. If I use words that don't make sense, or if I explain something too quickly, please raise a hand and tell me that you want more discussion. I'm happy to do it. So this is the core idea. If we're going to protect these things, we have to make sure that they're as diverse as possible. Diverse species tend to do well. They can evolve with their habitat. They do better. If you have a species, say, if steelhead can only tolerate maybe a 5-degree swing in temperature, they're not going to survive. We're going to lose them in the next 50 years. We're going to lose them in the next maybe 100 years, right? So if these things are going to stick around, if species generally are going to stick around, you have to protect that genetic diversity within the species. That's where our adaptive potential is. And the Endangered Species Act recognizes this and seeks to protect intraspecific genetic diversity. The way it does that, you can list species under the Endangered Species Act. And the Endangered Species Act defines species as, because this is the law, they don't just say species is a species. It's a species as a species, a subspecies, or any distinct population segment of a species of bird or fish or wildlife which interbreeds when mature. Okay? So we define species to mean species, subspecies, or distinct population, DPS. And this is really important because the EPA, or the ESA rather, offers an awful lot of protections, right? If you list something in the Endangered Species Act, you can't take it, I mean, you can't kill it, you can't harass it, you can't take its habitat. A lot of research money flows to the listing decision, so you get additional research funds to look at a species once it's listed. You get federal agencies always have to consult if they're doing anything that may impact the federal species. So getting onto the Endangered Species Act, or getting onto the Endangered Species list is a really big deal. And it's going to help these species a lot. But this is the core question, or one of the core questions, is this a listable unit? Right? Is this a species, a subspecies, or a distinct population segment? Species and subspecies, that's something that, I mean, science fights back and forth about what a species is or a subspecies is, but generally you can get some kind of consensus, or some kind of maybe rough consensus about what a species is for a lot of these different species. But this DPS is not a scientific term. You know, it wasn't used in the scientific literature before the Endangered Species Act came in. So this question is where an awful lot of the fighting has gone on. And this is particularly true for steelhead. Steelhead generally are very difficult to regulate under the Endangered Species Act. This is a picture of a big male steelhead. They color up like this when they're coming in for spawning. Is everybody familiar roughly with what steelhead are, or should I talk about that a little bit?
A little talk.
Okay, cool. So I gotta go one more slide and then come back to what they are. So steelhead are this fish, and they're, as I said, native to this huge range all the way from Southern California up across California, Canada, Alaska, down into Russia. And their environments, particularly if you think about here in the Central Valley, are very variable environments, right? These are not easy places to live. You have really dry years, you have really wet years, you have really dry decades, you have really wet decades. In a normal year, you have huge amounts of rain and huge floods that come through during the winter, and then streams that would dry up to a trickle historically during the summer. We've changed it a lot with the dams. That's what the historical environment looked like. And so one of my ideas here is that the steelhead are very difficult to manage under the Endangered Species Act because they're such a variable fish, and they're variable because of their environment, right? So this makes them very difficult. We'll bring this eventually as we go through the biology background to the law and kind of how we iron this out. So a little bit of information about the steelhead. Steelhead is an ocean-going rainbow trout. So it's a rainbow trout. Instead of hanging out in the stream all year, it's born, and like a salmon, after a year or two, it goes out to the ocean, spends a year, 2 years, 3 years, 4 years, 5 years in the ocean, comes back up and breeds, and then it's actually able to go back out to the ocean again. So it can breed multiple times, 2, maybe 3 times throughout the course of its life. So it's not like a salmon that does it once and dies. It can do it multiple times. They're obviously big, gorgeous fish, if you're into fish, right? It's a nice looking fish. The adult Central Valley steelhead generally up to about 60 centimeters long. Max size for those is probably 120 centimeters long, so that's a big fish. Normal size Central Valley is maybe 3 to 5 pounds, but you get fish up to 55 pounds. It's roughly the record for steelhead, which is, that's a really, really big trout. It's kind of, yeah, it's incredible. So when they're in the ocean, when they're small, when they first go out to the ocean, they're very silver, and they keep that kind of bright silver color, like think about a coho or a king salmon in the ocean, they're that same color. When they come back up to spawn, the males at least, in typical male fashion, go nuts. They get all brightly colored and gaudy to try and make themselves look good. They have a square tail, generally with spots across the entire tail, which is kind of unique among California salmonids. Salmonids, I should say, are any fish in the salmon family. So that's salmon, that's trout, there's whitefish is another salmonid. And kind of the key characteristic for those is a little adipose fin right here. It's kind of a little fatty fin. Catfish also have it, but catfish clearly aren't related to these guys. They've got the weird face stuff, not the trout face. So salmonids include, as I said, the steelhead. And on average, they live maybe 3 to 5 years, but they get up to about 11 years is kind of the max age you can see. So in California, the population we're going to look at is the California Central Valley population of steelhead. They live, obviously, from the name, in the Central Valley. These maps are a little bit hard to see. So this is historically the edges of their habitat, and where they would traditionally spend their time spawning are these upper reaches of rivers where the cold water is. So they move through kind of the central valley part of these rivers quickly into the headwaters where the water's cold, oxygenated, generally cleaner, and would spawn there. The babies would stay there for a couple of years and then would migrate out to the ocean, passing fairly quickly through these areas. Although we found out they spend a lot of time in floodplains too, so they're, as I said, a very kind of adaptable fish. We'll leave the other maps off for now. So as I said, these ecosystems, the Central Valley rivers, are tremendously variable. Precipitation changes a lot, both interannually, so winter versus summer, or interannually, sorry, year over year, and then intra-annual, winter versus summer. Over the longer term, over the decades period, and, we'll talk about 50-year droughts, which is, I guess, a terrifying thing to even think about right now. But historically, this is the regime that these fish have been exposed to. And so they needed to be a fish that can survive having a river that's dried up or dried up in its lower reaches for significant periods of time. That affects, as I said, the connectivity of the river. If you can't get from the headwaters to the ocean, it's kind of hard to be an anadromous fish, right? If you, anadromous meaning you can swim out to the ocean and come back up. You can't do that if you've got 50 miles of sand between the end of your river and the start of the ocean. Water temperatures range quite a bit, both temporally, so summer water temperatures are much higher than your winter water temperatures, and spatially. You've got very cold waters upstream and very warm waters downstream. So these fish have to be able to handle that variety. Due to your precipitation, due to the geography and geology of California, you see fairly frequent land wildfires and landslides then after those fires when you get major rain events. This isn't a new problem, right? This has been going for thousands of years. And this is, I call it stochastic variability, right? It's not predictable, it doesn't happen on a cycle. It happens kind of randomly, but it's going to happen randomly fairly frequently on a 500-year time scale or a 1,000-year time scale. So certainly in an evolutionary sense, it's going to affect these fish. You get volcanic eruptions, and you get big changes in ocean conditions here. El Nino, La Nina cycles, amount of upwellings going on in a given year, amount of water coming down from Alaska. Huge variability. So why do we care about this? Because that has changed the way that steelhead behave. It makes steelhead very flexible or very plastic in their life history. Life history is kind of your pattern of being born, maturing, reproducing, and eventually dying. And steelhead do this flexibly, right? They do this in a lot of ways. They're anadromous, meaning that they are born in these rivers, they get the good conditions for when they're really small, then they move out to the ocean and get really good ocean conditions for a period of years, and that lets them grow really quickly. They want to grow quickly because big fish have more babies. And that's what you want to do, right? If you're, in an evolutionary sense, having babies is good. So you want to go out to the ocean, get really big, come back, have lots and lots of babies, your genes keep going. And it's a big benefit for them over, say, rainbow trout that stay in a stream all the time, because those fish, they aren't getting up to 55 pounds, right? Think about how many eggs a 55-pound female fish can handle. That's incredible. That's a ton of eggs compared to like, a 10-inch, which would be a big rainbow trout from some of these small streams. They're very flexible when they move out of the streams. Maybe after a year, maybe after 2 years. It depends on how quickly they grow. Depends on the water conditions in the stream. So they can do this in a whole variety of ways. In migration, when they come back in, they can come in early in the year, some come in late in the year. There's actually the steelhead different runs. There's a winter run that comes in very late. There's a summer run that comes in during the summer and stays in those headwater streams all summer long. And that's, again, kind of a risk spreading strategy. If your river is going to be close to the ocean at some point, it benefits you to have parts of your population come in at different parts of the year, so at least some of those fish can actually make it up while the river's open. And then again, age of maturity. They may be sexually mature at a year, or 2 years, or 4 years after that much time in the ocean. It's just a huge range. Complex population structure, opportunistic use of habitats. There's a whole lot of things they do to adapt to that habitat. And it's just fascinating looking at the way they've adapted to this. But what we're going to focus on is this idea of anatomy and how it's different than the rainbow trout. So if you think of this as kind of the ideal pattern for a steelhead. Mama lays the egg, incubates them. The baby's born, they come out of the gravel, they hang out in the stream for a year or two, maybe move down to the estuary, go out to the ocean to smolt, grow in the ocean, come back out as these big fish that have lots of eggs and lots of sperm, milt in a fish, spawn, and the cycle goes again. All right, this is what you learn for salmon. This is kind of the typical idealized life history. It's also not really at all what's going on with steelhead. What we found out, and we really only found this over the last maybe 20 years, there's some suggestion before that, but we didn't have the chemistry or the genetic work to really understand what's going on prior to maybe the last 20 years. What we found is that these eggs and then these fry that emerge, when you have two steelhead parents, they're not necessarily going to produce steelhead. some part of the time they actually produce rainbow trout, steelhead that never go to the ocean. And when you have rainbow trout parents, they produce some percentage of the time steelhead that do go to the ocean, which makes it really hard when you're trying to protect steelhead and you don't care about rainbow trout. Right? There's a ton of flow between these populations. This is just for comparison, that's a big female rainbow trout. And this is, big female steelhead that came out of the ocean, and this is a smaller trout. You get a feel for the difference in size here. This is actually a female rainbow trout here, breeding with a little male, or female steelhead, sorry, breeding with a little male rainbow trout. So the big one went out to the ocean, and then you got this tiny little sneaky male, right, that comes in and is able to breed. And he's super excited because she has so many eggs, and so it clearly benefits him to breed with her. And I think she's pretty tired. She's too worried about it at this point. But there's a lot of breeding that goes on between the two different, what we thought of for a long time as different species, right? We found that this just not, our normal conception just isn't true. Residents birth steelhead up to about 20% per year, depending on where you're at. So 20% of the offspring from 2 resident parents can be steelhead. Steelhead parents birth resident offspring. We don't really know the rate on that, but it's clear that it's fairly high. There's been some studies of fish in the Central Valley here looking at the genetics, and they found out of 700 rainbow trout, roughly 200 of those had steelhead parents, had 2 steelhead parents. Resident rainbow trout that were taken from the Sacramento River and moved down to Argentina to create a new population there. So you pick resident rainbow trout up here, you take them down to Argentina, put them into the river there, thinking you're going to create a resident rainbow trout population. Have given rise to a steelhead population down there. So there are rainbow trout, but there's also now a steelhead run in Argentina that came from purely resident rainbow trout. We don't really know what's going on. We know part of this is genetic. Some of it is how quickly they grow and how fast they achieve a big enough size to survive in the ocean. But a lot of it seems to be kind of random. So it's fascinating. It's really kind of biologically cool. It's also really challenging when you start talking about how we manage this under the Endangered Species Act. So now we're going to shift back from biology into a little bit more of the policy side here. The populations, in spite of their plasticity, in spite of what a cool fish they are, have not done well. That's kind of an easy, soft way of saying it. This is the annual numbers of naturally spawning steelhead in the Sacramento River upstream of the Red Bluff Diversion Dam. And I'm showing this mostly because it's emblematic of the decrease since the 60s through what we've got right now. Historically, a lot is there may have been a couple million of these fish in the Central Valley. The number right now is, it varies year to year, but it's in the 10,000 fish in the wild fish range.
So if it's upstream of the dam, is there a fish ladder?
There is here. They're able to move around here. An awful lot of the dams that we have, though, are terminal dams, right? You can't get by them at all. And that's been the single biggest cause. If you think back to that map we showed early on of the Central Valley and where these fish were, and if you overlay that map with a map of where the dams are, the dams tend to start kind of where the steelhead habitat stopped. And so they can't get to their historic habitat. There are now resident rainbow trout populations upstream of those dams that probably have a lot of steelhead genetics mixed in, but the steelhead themselves now have to breed below those dams. So a lot of that breeding is done in hatcheries. The dams do change the river conditions enough that steelhead are actually able to spawn naturally there. So you think about, maybe the Feather River is a good example. There's a steelhead hatchery there, but there's also a wild run of steelhead that breeds in that river. And historically, the river in that area would have been too warm for steelhead to get by. But they can do it now because of the cold water coming out of the bottom of the dam. But generally, it's been bad. And that's dams, that's water diversions, conversion of riparian area, introduced species that prey on these striped bass tend to seem apparently to eat steelhead. Some people don't think they do, some people do. If you're a striped bass fisherman, generally you don't think that they do. And if you aren't a striped bass fisherman, then you think that they probably do eat the young. Poor hatchery management of the hatchery populations. All those things together have shown just a huge decrease.
What about floodplain loss? Is that thought to have an effect?
Absolutely. So there's been some really good work out of the Watershed Science Center at UC Davis looking at growth rates of salmon and steelhead in floodplains. And they grow much faster there than they do in estuaries, than they do in the rivers themselves. I don't think I have a picture now, but if you look at historical maps of where floodplains were and where the wetlands were in the Central Valley, essentially the entire area around the bay would turn into a giant floodplain during the summer. It would be flooded, those fish would be able to move across those. They're super fertile habitats. You got amazing insect growth. When you flood an area that's been dry, you kind of got all the nutrient, the leaf litter, all that stuff that's been sitting there waiting for the water. The water comes in, the bugs come in. These fish come in and they eat those bugs. So you get incredible growth rates, and the loss of that certainly is a loss of rearing habitat. The work they're doing now is actually looking at ways to integrate rice farming with floodplain growth and salmon. So you can slow the rate of water outflow from a rice field. If you decrease, I think it's roughly 7 or 8%. If you don't go any faster than 7 to 8% per day, then that gives all of those fish a chance to migrate out off of the floodplain before it goes completely dry. So the fish survive, the fish grow really well there, and the rice grows really well. So there are solutions, little rays of hope in spite of the charts like this. That's a good point on the wetlands and the floodplain habitat. So we've got a problem. Clearly we need to list the steelhead. But as I said, this species exists over a huge range. And throughout a lot of its range, it's not in trouble. Right? Your steelhead populations in Alaska and Russia are great. A lot of them in Canada are just fine. Even ones through kind of northern California, they're starting to run into trouble still in Oregon and Washington. But there's a lot of healthy populations out there. So when you talk about protecting the species, you can't just say, we're going to list steelhead, period. Right? It's in too good a shape to be listed under the Act. It's not, in fact, in danger of going extinct. But populations like this are. And as I said earlier, these populations, populations like the Central Valley steelhead, are populations that have historically been exposed to very different environments, to really warm rivers, and that are adapted really well to surviving those higher temperatures. So if you want to protect steelhead generally, you have to protect populations like this. So we're protecting things at the population level. That brings us back to the question of what is the population here? And the National Marine Fisheries Service, which is an agency within the National Oceanic and Atmospheric Administration, NOAA, which is in Department of Commerce. There's a whole lot of acronyms here. All you really need to know is National Marine Fisheries Service oversees the listing of marine species and anadromous species like the steelhead. So they're responsible for deciding whether those are listed and then for managing them after they've been listed. So they do the whales, they do the seals, they do all that endangered species work. The problem, and where it starts to get interesting, especially with these resident fish, is that the Fish and Wildlife Service is also responsible for administering the Endangered Species Act. And they do dry land animals, they do freshwater creatures. So now, right, now we're getting interesting because you've got this population that you want to list. You want to protect just the marine component of it, but it's got a freshwater component too. There's a lot of breeding that goes on between that freshwater component and the saltwater component, and you have two different agencies that are supposed to be overseeing these fish. And so you're clearly going to have an agency conflict here. And if you know anything about agencies, you know they like to protect their own turf. They don't like other people coming on and trying to tell them what to do with their money or with their species or with anything that's within their power. And so when you've got National Marine Fisheries Service trying to decide what to do here, and Fish and Wildlife Service also sticking a claim to these things, you're going to have some pretty serious headbutting going on. So in 1991, National Marine Fisheries Service puts out a policy defining this term, distinct population segment, specifically for Pacific salmon. And they don't mean salmon, they mean salmon. So the salmon and the trout. Well, not the trout because they don't have to oversee those. All right, so the salmon and the steelhead on the Pacific side of the country. They did this because they needed to start making rules to figure out how they were going to list these species. They tried to work with Fish and Wildlife Service. Fish and Wildlife Service said, we're not that worried about doing it right now. We're going to have a really hard time agreeing with you on anything. So you guys go ahead and figure out what you want to do with these species and we'll leave it alone. Okay, so they published this policy in 1991 explaining what a DPS is. And they really clarified it because they said a DPS is an ESU. Right? That makes it clear. If you wanted to find an acronym, just create another acronym for it. It's primo. An ESU is an evolutionarily significant unit. This is the term. Robin Waples was the guy who did a lot of work on this. And he said there have to be two criteria to be considered an ESU and thus a distinct population segment. One, you have to be reproductively isolated, so you can't have a lot of interbreeding going on. The focus there is really on gene flow. And then two, it has to represent an important component in the evolutionary legacy of the species, which is a hard thing to define, but the reason this came up is that there was a lot of complaints just before this DPS language was added to the Act that we were going to end up protecting like squirrel populations in different city parks in the city. Because, hey, if they can't cross the streets and get from one park to another, then you have reproductive isolation going on. And sure, the genetics are probably all the same, but they'd be separate populations. And so this component is supposed to keep that from happening. Okay, so you have to have some differences here, such that this population is significant to the rest of the species. Maybe it's unique habitat, unique life history form, whatever it is. You have to find a way to show that it's an important component of the species' broader evolutionary legacy. Okay, so National Marine Fisheries Service does this in 1991. 1996, Fish and Wildlife Service is ready to play ball, and so they sit down with NIFS, this is National Marine Fisheries Service, and they develop a joint policy actually defining distinct population segment. which NIM said, yes, already done once, but we're doing it again. This is going to be broader. This isn't just for salmon, this is for everything. And here they said one population has to be discrete, which is like reproductively isolated, except that it's not as focused on genetic flow and on interbreeding. It's more focused on kind of the ecological discreteness of this population. Okay, so the way that this particular population interacts with its environment, that can be enough without getting into the genetic side of it. And then two, it has to be significant, which is kind of very similar to the important component of the evolutionary legacy. So joint policy in 1996, National Fisheries Service is kind of invested in this 1991 policy because, hey, they've been making rules based on it already. And if they've been using it, they don't want to throw it out the window. So the agencies agree that the ESU policy is just a special case of this broader distinct population segment. They're not inconsistent. This is just a little more restricted with what we're going to use for Pacific sunlights. Okay? Everybody good so far? All right. Let's add another layer. 1996, National Fisheries Service proposes to list Central Valley steelhead, the ESU, as endangered. And they said it's going to be only the native naturally reproducing fish. We'll carve out the hatchery fish. There's a separate big fight that went on with hatcheries that we're going to kind of skip over today. And their ESU that they defined included resident fish. Because there wasn't, they said, reproductive isolation between...
What's meant by resident fish?
Those are the trout that never go out to the ocean, not the anadromous fish.
So the rainbow trout, right?
Exactly.
Okay.
So we're going to say, we're going to include all the rainbow trout that are downstream of dams in the same places that we have steelhead. We're going to list these, and scientifically it makes sense, right? They're interbreeding, they're doing things like the one population. Not completely integrated, but fairly integrated. And they looked at it and said, yeah, this is an important component, and said, if we say that this includes those resident fish, it's enough reproductively isolated from other populations of steelhead that we can list it. So as long as we include the rainbow trout, we get that reproductive isolation. If you don't include the rainbow trout, it's really hard to say that you're reproductively isolated enough to be an ESU. Everybody good? Okay. So that's a proposed rule in 1996. They're going to move forward, they're going to list the species because of the huge declines. 1997, Fish and Wildlife Service said, whoa, whoa, that's our territory. They started sole jurisdiction, meaning just their jurisdiction, not the fish, the sole, right? This is just our jurisdiction over these resident steelhead, i.e. rainbow trout. Rainbow trout are our fish. Any listing decision regarding rainbow trout rests with the Fish and Wildlife Service. That's a direct quote from their letter. I said, maybe you can treat these as separate DPSs. You cannot make this one ESU and list and protect these resident rainbow trout. And they absolutely refuse to support NIMS going forward in listing the population, including those rainbow trout. You can't do it. Maybe NIMS could have gone ahead and done it, but then if a court ever looked at this, the court would have had a really hard time saying, yeah, we're going to defer to this agency when two agencies that both have jurisdiction over this disagree in a serious way.
If they listed rainbow trout, that means you couldn't fish them anymore, right?
Right. And actually you can't fish the ones, well, I'll get to it at the end, but the way California has played this out is kind of an interesting way to handle the whole thing. So 97, Fish and Wildlife Service says this isn't going to work. NIMS then publishes the final rule in March 1998, lists the California Central Valley ESU as threatened. They say in their listing that the ESU includes the resident rainbow trout, the fish that aren't going to the ocean. And then they say we're not listing that part of the ESUs. We're only going to protect the steelhead. We're not going to protect the rainbow trout. So, yeah, okay, you're part of the ESU because biologically we've got to do that, but we're not going to list you as threatened.
Kind of a little lost in acronyms. ESU, what does that stand for again?
Evolutionarily significant unit, and that's how they define the population.
Okay.
Right, cool. So, really what NIMS is doing here is just getting super smeared its definition. Yeah, biologically you're all together, but for policy purposes and legally, we're going to treat you as separate, even though you're interbreeding, right? Okay, okay. They can do whatever they want until they get challenged. And you see a challenge in the district court in Oregon, federal district court in 2001. This is the Alsea decision, Alsea Valley Alliance v. Evans. And don't want to worry too much about the case itself. Here, though, it was a hatchery issue, and the National Fisheries Service had done something similar in Oregon and said that the ESU includes hatchery fish because the hatchery babies interbreed with the wild babies, so we've got to put them all together into the same population, but we're not going to protect those hatchery fish, we're just protecting the wild fish. So, you may have heard the story, people are standing out in the river, like literally clubbing the salmon that have come back that are hatchery salmon, and letting the wild fish go. And so they're killing fish that are genetically very, very similar or almost exactly the same because of this rule, right? So I'll say to Sue's,
Can they identify?
so in the hatcheries, they cut off that adipose fin,
Okay.
which is apparently a mostly useless fin as far as we can tell, right? They cut it off, and if you catch a fish without a hatchery, without an adipose fin, it's a hatchery fish. If it has a fin, then it's a wild fish.
You can keep it.
Yeah, then you get your choice. You can keep it and eat it, or you can let it go. So I'll say a Valley Alliance sues Evans, who is the Secretary of Commerce, because he's the one all the way up all those levels we talked about, who's in charge of the National Marine Fisheries Service. And the court says, yeah, you know, the ESA says that you can protect species, subspecies, or distinct population segments. And if you say an ESU is the same thing as a distinct population segment, that's fine, but you can't get smaller than that. The Act doesn't let you do anything with populations smaller than that. You can deal with species, subspecies, or distinct population segments, but once you define a distinct population segment, you can't protect half of it and not protect half of it. If this is a population, you treat it as a population. You do the same thing to it. And that creates all kinds of problems with how we manage hatchery fish, and in this case, how we manage these resident fish. I think the court, I mean, frankly, is probably right. It's hard to see how you get away with doing this, right? So after this lawsuit, National Marine Fisheries Service has we got a problem. And sure enough, you know, maybe half a year later, another lawsuit gets filed, and this time actually dealing with these resident fish in California. NIMS doesn't even contest it, and they say, yeah, you're right, we're going to redo the listings. And so they go out and start new listings for all 27 species that they were species, subspecies, or distinct population segments that they've listed on the west coast of the United States. So, remember this is 2001, so about 3 years later, they finally get the draft rule together. Proposed listings in June 2004 for the California Central Valley ESU go back to including the resident fish, because these resident fish interbreed. Resident rainbow trout and steelhead in the same area generally share a common gene pool, at least over evolutionary time periods. And what that translates to is these fish are interbreeding, so we are going to consider them as part of the same ESU. This was reviewed by 3 big science boards in California with kind of their biggest experts on genetics and on California fish, and they all said, yeah, this is the way you should do it. This is the right approach here. But we've seen this already once, right? As soon as they say we're going to list this, we're going to include the resident fish, we get another letter from the Fish and Wildlife Service saying, no. Fish and Wildlife Service understands that National Marine Fisheries Service has conducted assessments on both life history forms. As you know, we have ESA jurisdiction over the anatomist form, and the Fish and Wildlife Service exercises its jurisdiction over the resident form. Even if listing is warranted, the Secretary of Commerce doesn't have jurisdiction to undertake a listing action for the freshwater fish. Fish and Wildlife Service says, we are not going to let you list our rainbow trout. And part of it's the Fish and Wildlife Service would have to then spend money to protect these fish, to do the recovery plans for it. They don't want to spend the money to do it. They don't want that additional responsibility. And they don't want another agency making decisions over a fish that they believe that they have jurisdiction over. So we get another letter. Probably saw that coming. National Marine Fisheries Service apparently didn't see this coming. It says, oh, we need another 6 months to think about this. They do this kind of special 6-month extension, and then asks for comments on using the distinct population segment policy to list steelhead. This is a big deal. Remember, we talked about the ESU says substantial reproductive isolation. We're looking really at, is there gene flow going on here? The DPS policy, which is broader, says market separation. And these 2 agencies have said since 1996, when they published their joint policy, that these are the same thing. The ESU is just kind of a specialized version of it. Turns out that's not at all true. If they're saying, hey, maybe we can list this differently if we list it as a DPS and not an ESU. So this is a major change from the way they've done it. They've used this approach for 14 years. That's 14 years worth of listing decisions, denying petitions, say, for the Klamath Province summer steelhead because it doesn't qualify as an ESU. It might qualify as a distinct population segment, but they never looked at that. That wasn't how they made the rules. So they're looking at this as a way to solve this problem, potentially opening up a whole lot of other problems. So they seek comment on this, and then publish a final rule in January 2006, embracing the DPS policy and applying that to steelhead, and saying, under the DPS policy, we can list steelhead, not list rainbow trout, even though those 2 populations interbreed. It's different enough, kind of in an ecological sense, that we can list them separately. And so they exclude all those resident fish from listing. And this is a nice little twist they pulled at the end. So the Endangered Species Act says that if you list a species and it looks just like a species that you're not listing, you can protect that species that you're not listing under a section called Section 4D, Similarity of Appearance section. So if you have something that looks just like a listed species, you can list that thing that's not in trouble at all in order to protect the listed species itself. So the way it plays out here, because young steelhead look just like a rainbow trout, the National Marine Fisheries Service protects all the rainbow trout in areas that have access to the ocean under Section 4D. So if you're fishing in those, to go to your question, you can't keep wild rainbow trout from those streams either, because they might be baby steelhead. Even if they're not, they might mate with steelhead, or they might produce steelhead when they have babies, but they didn't get into that at all, right? This is kind of an end run around Fish and Wildlife. Fish and Wildlife is mostly okay with this because it's not taking anything jurisdictionally away from the Fish and Wildlife Service, and it's not forcing the Fish and Wildlife Service to do recovery planning or anything for the rainbow trout. All that they get there is a protection from take. So ultimately, they get it, right? They protect it. And it's this fascinating intersection of biology and the policy and the law and how it all kind of fits together or doesn't fit together in the end. So let's see. This is in 2006. In 2008, Grange files a lawsuit against the National Marine Fisheries Service. It says, no, this isn't really okay. You can't just change your mind and use a new approach to listing these things. And even if you do, you're still treating things that are essentially the same differently. District Court here, the Eastern District of California says, no, this is fine. This is just a shift in the way they do things. Agencies are allowed to change their mind over time. They've learned something from getting 2 letters to the Fish and Wildlife Service. They're taking a new approach to doing this, and it's okay for agencies to change their mind. We're still going to defer to their decision. So the District Court rejects the challenge and upholds this approach to listing. Goes up to the Ninth Circuit. This Modesto v. Gutierrez case. It's really confusing when cases change names, but it's actually the same case and the same litigants and everything. So same exact case, and the Ninth Circuit upholds the District Court, and then the Supreme Court doesn't take an appeal on this. So this is it. This is done. This is now the law in the Ninth Circuit, and this is the way they can do listings going forward. And they can always change their mind again. We've seen agencies can do that. But right now, this is the lay of the land, and this is the way that, at least with steelhead and with these populations, the agencies decided to manage these. So it's a neat story, and it's really interesting the way it all fits together. Where we are right now, we know that this population is protected, the wild resident fish are protected, the populations themselves are still in decline, and that's, this doesn't take care of that, but at least gives us a chance to continue working to save these fish. It's still not clear what you do biologically. We know what we're doing in a policy sense, but biologically about these resident fish versus the anadromous fish, we don't have good counts in the resident fish because we had historically been stocking fish in a lot of these areas, and there's a lot of interbreeding going on with those fish. The other thing that's really interesting, if you think about why steelhead went out to the ocean in the first place, why do they care about going to the ocean? It's because these rivers were often not great places to live during the summer, right? They're hot, they're dry, there's huge variability during the year. They go out to the ocean, lots of nutrients, they can get big. But what we've done now is to build all these dams on the rivers. And if you think about what's happening downstream of the dam, that river's cold year-round, that river has minimum in-stream flows year-round. If you're a fish and you're looking for a place to live, if you're especially a steelhead that needs cold water, that could be a really good place to live. And so it looks like we may actually be selecting for resident steelhead now with those ecosystems, as opposed to the selection that's gone on historically for steelhead, because we're making the habitat too good during the summers. Does that mean you turn the water down? Probably not. The steelhead are not in great shape, right? Just a little push and they deal with the break.
This summer there won't be much cold water.
Yeah, maybe push them out. But it's not clear kind of how we can do this going forward in order to maintain that particular life history form that socially and culturally we're really attached to, and that has a significant component of the genetic legacy for all of these fish. And it's not clear how important these resident fish are to maintaining steelhead in the long term. We're protecting them right now, but they're still isolated from an awful lot of the resident fish. There's some really recent genetic work looking at residents upstream, looking at rainbow trout upstream of dams, and it looks like those fish may actually be the closest genetically to what we had historically for steelhead. And we're not using those fish at all in terms of bringing them in and putting them in these populations. So maybe there's a way to bring in that legacy as well. So kind of a lot of good research questions here. Kind of the legal side of it is, if we're changing the way we do this, if you change what you're doing for these steelhead, what does that mean for all of the steelhead populations that you refuse to list in the class? Those summer-run Klamath fish. So could the Klamath Mountain Province summer steelhead be listed as a DPS? They've said, well, they're not reproductively isolated, so they definitely can't be listed as an ESU, but we don't really need that for this distinct population segment approach. So maybe we need to go back and relook at a lot of National Marine Fisheries Services past listing decisions. Maybe we need to look at Chinook salmon again and see if there are other runs of salmon that could be protected that haven't been protected in the past. So I think that's the kind of legal side of this. More broadly, if the DPS is the way we're going to be moving going forward, we need to look at how much of that 1996 policy is still in play. When we think about how much what NIMS has done has changed since 1991, think about what we knew genetically in 1996 versus what we know now. It's not clear at all that that policy is really what still drives the services. The services tend to rely on that, especially in the rules and the court decisions. And so going back and seeing how true they actually are to that in their listing decisions is a really interesting question. And there's broader legal questions about kind of deference and how much they're going to defer to, how much courts should defer to their agencies when they can change their mind in a way like this. Animal biology work. And that's really about it on these. I'm going to open it up for any questions people have about that.
I have a question. What if that decision gone the other way and they had said, you know, these are not genetically distinct populations, they need to be protected as a unit? What would be the on-the-ground effect to the management of the rainbows? I mean, you can fish rainbow, right?
So, and if you're, so like someplace like the Feather River or the American River here, if you catch a rainbow trout that has an adipose fin on it, then you have to let it go.
Yeah.
If it's got clipped, then you can keep it. Right? And upstream of dams, it's fine because they're not protected there. You know, it's a really good question. They were lucky in this case. They got a really good judge. The judge, I think it's the same judge who's done a lot of the Delta smelt stuff. He's a judge who takes his time, tries to get the science right, and really tries to dive in and understand what's going on with these issues. So, you know, part of it is that they did get a good judge, and the Ninth Circuit just upheld that decision. Ninth Circuit's generally a fairly liberal environmental court. But so what we do if you didn't have that, I think you start looking at, do you include those above dam rainbow trout in these populations? There's no gene flow now, but historically there was. Peter Moyles looked at this a little bit from UC Davis, is the big fish guy there. He said that if you include those fish from above dams, there may be too many fish to list. These populations might be in good shape if you're considering resident trout above and below dam and the steelhead life history for them.
But you have to let them do their anatomy.
So you've got to get
you
it
have to
downstream.
take the dams out or alter them with money and
Truck them
fish
around.
ladders,
Yeah.
etc. And that's the big.
You can't truck them around.
Right, and so you catch those fish and move them down. You know, I think it would have really significant impacts for how we manage these fish. I suspect National Marine Fisheries Service and Fish and Wildlife will go at it again and try and hammer out some way to make this work, and then hope they get a different judge the next time around.
So that kind of answered the second part of the question, which is the rainbow trout really aren't in danger.
No, I mean, above dams, they're generally in good shape, except that they've had hatchery fish dumped on top of them. It looks like the hatchery fish and the wild fish don't actually breed a whole lot, because the hatchery fish are just so completely different an organism than a wild fish that there just isn't a whole lot of gene flow there. But upstream of dams are in good shape. Downstream of dams we don't know. We've always thought of them as steelhead. And so there's not a whole lot of work being done on what's going on with these fish. It's the same thing with salmon. We found that some baby salmon never go to the ocean. They hang out in the river for a year and then they breed and die. And we only found that with snorkel surveys in the last literally like 5 years. And you can go on YouTube and watch the videos of these things, and all the scientists are just, just what they're supposed to do. It's incredible. It's great. I love it. But yeah, it's a very quickly evolving area.
So I'm absolutely fascinated as well by the decision-making part of all of this, and how much that relies both on what's possible under this legal regime and on particular understandings of, say, the species concept. So I'm wondering, from your perspective, what's the big policy lesson from this entire case study of the steelhead and the rainbow trout? How can we use this to think about future environmental policy?
I think that's, so, yeah, I feel like I'm just bringing this back around to this whole kind of approach that we're trying to take here, this idea of interdisciplinary work. For almost any agency decision, when you're relying on science like this, if you make that decision correctly, if you do kind of the right kind of analysis of the science and of different possibilities, you can get that decision upheld a lot of the time. Which is, I don't know if that's the realistic or the terrifying way to look at this, but agency decisions get a lot of deference, and if you look at the right things and consider the right things early on in the decision-making process and not tacked on at the end, you can get those decisions upheld. So the lesson to me is that, one, we have to win the battles at the agencies in terms of where people engage and where people do their advocacy, you have to work at the agency level before it gets to court, because it's very hard to correct those decisions later. So I think early engagement is the broad feeling here. Any advocacy work needs to be done at agencies first before you ever get to court. And then the other thing is you need to get people early on who see that big picture that you're talking about, right? If you have scientists who are trying to make this decision, that's how you run into letters from Fish and Wildlife Service every couple of years saying, no, this approach still doesn't work. So you need to have lawyers or at least really good people who understand the policy side of it at the table making those decisions very early on. Because just being engaged enough that they can say, whoa, I don't think this is going to work, or if you're going to do this, you really need to take X, Y, and Z steps before you do it, makes those decisions upholdable at the court level later on. So I'm not sure if that answers your question, but.
That's really interesting for the agency as the locus for advocacy by all of the parties involved. How do you see agencies responding
So,
to that? Are they attempting to foment that kind of engagement at that level? Are they?
So there's actually, under the Administrative Procedures Act, which is the act that kind of governs how agencies make decisions, there's a couple different ways you can do a rulemaking. You can do a formal rulemaking, which is actually like a trial at the agency. You bring in witnesses, you get testimony, you have competing sides making different arguments, and then you make a decision that's published. All of that stuff goes into the record, and that's your decision. And that's a new rule going forward. It's super expensive to run a trial, and agencies don't like doing it. They don't like the confrontational aspect of it. They don't like having the press there for this big thing. It's very hard to do quietly, and so they tend to shy away from that, although for a lot of these things it seems to make a little more sense. They do, the other two kinds are formal and informal rulemaking. And informal rulemaking is really just all the decisions they make without a whole lot of process. Letters they write denying a permit or granting a permit. But formal rulemaking is where you go in and you actually write a draft rule. Is what we saw here. You write a draft rule, you publish that rule, and then you get comments back on that rule, and then you publish a final rule. And there's a big system that's been built up around that. What's in the APA is very simple. You publish a rule, you get comments, you consider the comments, make a final rule. What courts have drafted onto that is to say, look, if we're going to be able to assess these decisions that you made and make sure that they're in keeping with the law and keeping with the science, you need to put together a record of all those comments, and a record of everything you've considered in making this rule, and a record of how you've responded to those comments. And things that get a rule thrown out is when they don't consider a comment, or if they use kind of internally inconsistent logic, it gets pointed out in a comment and they still go forward with it anyway. And that's where you get into trouble. And so the courts have made them accountable to these comments.
So that interface between the regulatory apparatus and the courts is actually quite key to the
setting
to
up
the
this whole,
weight of.
exactly.
I find that absolutely fascinating.
And it's all created by the court. Because, the APA itself is very simple. Like I said, you just publish a rule, get comments, publish a final rule. And then the APA says you can't be arbitrary and capricious in your rulemaking. And everything else past that has been stuff created by the courts, laid on top of that to figure out how do we assess whether this happens or not.
This is interesting in terms of, so I've been doing some work with the Union for Concerned Scientists and Center for Science and Democracy, and part of their big question right now is trying to find what is the locus of decision making, where do we want to insert scientists? And it seems like you're saying that this rulemaking process, formal or informal in the agencies, is the locus where.
It's where you have to, and it's so much easier if you can say, look, we told the agency when they published the draft rule, we told the agency when they published the final rule, and now we're suing the agency because they didn't listen to anything that we said. It's a very easy case for a lawyer to take at that point. If you come in after the fact and you say, hey, here's the science that says this rule is wrong, you really, at that point, have to instigate a new rulemaking, ask them to change that old rule, and then if they don't follow the new science, then you can sue them and say that their decision's arbitrary there. So that's definitely where it's at.
So the final decision for this Central Valley ESU DPS came down to the genetic difference. Is it substantial or is it marked? So what level of percent? Because it's going to come down to a number.
So it's not just that. So under the ESU, so the ESU says substantial reproductive isolation, and you can quibble about how much gene flow you can have there and still have substantial reproductive isolation. DPS says marked separation, and so it actually shifts a little bit away from the genetic focus onto how do these things interact with their environment. So what they look at is the physical, physiological, ecological, and behavioral factors in addition to just the genetics. And that's why you're able to distinguish here. It's not like, oh, these fish are 30% similar. and not 20%, and so now we're going to separate them out. These steelhead are physically way bigger, they're physiologically able to tolerate salt water. The way they interact with their environment is by moving out to the ocean, coming back.
Yet 20% of the rainbow trout will turn into that form.
Right.
That's where I'm like, what's the percent there?
There's
Even
not-
accounting for all of that, right? You've got this huge phenotypic plasticity in these things.
Right.
Part of which is genetic, because of what we're seeing. If you can take 20% of those and turn them into this, that to me is the tipping point.
Something
for the
sitting there
decision.
waiting to be turned on.
Yeah.
Yeah.
And part of that might be an interaction between the environment
It seems to
and
be
genetics. But to
growth
me,
related.
it's
Yeah.
if the whole story is about protecting that phenotypic plasticity, and we're cutting it in half by
Completely.
doing that.
Yeah. No, I don't think there's an answer per se. And there's not a certain cutoff percentage-wise in the genetics. And that's why.
So there aren't any of those? I mean, are they, what are they finding with the reproductive isolation across the gradient? 'Cause another question I had was, is there a correlation between, so what is really interesting about the California ESU, or the Central Valley, excuse me, is that we do have this dry,
Right.
island in the middle of their breeding habitat.
Right in their habitat. Makes it super hard.
And do you not get that? So is the phenotypic plasticity particularly marked here? In other words, do you get 20%, 30%, 40% of the rainbow trout population turning into steelhead here? But you go to Washington, you go to British Columbia, you go to Alaska, and that's not happening. That would help turn up
Yeah.
the idea that
I
the
suspect
overall
it
the
is.
plasticity here. I would think so too, but
But
that
it just-
hasn't been done.
The works, it's really hard to do because it's not like there's a genetic marker for this is a steelhead or isn't a steelhead.
Exactly.
And so grabbing a particular fish and figuring out what the parents were is hard to do. You can do it with the otoliths, looking at I think it's strontium and chromium ratios in that.
Whether they've been-
The otolith is a little bone in the ear, and it varies between the ratios vary between freshwater and saltwater. And you can actually tell, apparently, and it's not entirely clear to me how this works, but you can tell what the mother was based on what's at the very kind of center of that otolith. So you can actually get to the maternal side of it, at least. But if you can imagine looking at tiny bones inside fish ears, this is expensive and hard to do work. So it's just in its infancy right now.
And you have to kill the fish. I'm excited.
Yeah,
I'm
just
excited too. Yeah.
Take the heads. Yeah.
Which
Yeah.
means it's not, yeah.
That's why it's much easier in salmon because they all die, right? And so you just go and you're picking up dead salmon heads off the river. For the longest time,
That sounds like a summer internship.
Oh.
I don't know.
for the longest time I thought I'd see all these salmon in the river and they were all in half with like a clean line through them. And I'm this Kansas kid and I'm seeing these salmon and I'm like, why do the salmon break down that way? Is that some kind of strange? And then I finally, the guy I was with was like, no, you idiot. They cut the salmon in half when they count them. And once they count the fish, they know how many fish have died in the river. And when they go back, they only count the salmon that aren't cut in half. Like, that's a great theory, you know?
All right, so we've got one more question.
I got a question for you about, I kind of want to know what, based on your analysis, what variables go into deciding what gets to count or not count on the Endangered Species Act? I mean, you've talked about the way in which the administrative agencies resist the science until you sue them. There's got to be reasons for that. I kind of want to know what's your explanatory variables about determining when an agency is responsive, non-responsive. I'm looking at those dams and the water levels. I'm thinking, Shasta's been there since '45, Oroville since '68. Red Bluff's diversion dam's been in there. What's changing? What's changing in the policy climate, in the responsiveness of these agencies? What variables do you identify as identifying an agency that's more responsive to changes in science versus agencies that say, this is the way we've always done it, we're going to keep doing it this way?
Right. So I think that's a really good question. And I think part of it goes to how you see these agencies, right? You can view, this is something I think would be really helpful to teach undergrads or law students in a class at some point, kind of ways to view an administrative agency. Do you think of an agency itself as a single rational actor making decisions about what it protects, what it does, right? As a single kind of monolithic entity? Do you look at it as maybe a collection of processes that it goes through, these rulemakings we've talked about, where once you start, you go down this route, and whatever you get is what comes out of that process? Or do you think of it as a collection of individuals who are all working and competing within this agency with different agendas, your political folks, your folks who are career people, your scientists, all working sometimes at cross purposes, sometimes in the same direction, trying to achieve certain outcomes, at the individual level, and from this kind of random morass, a decision emerges out of that. I think, which view you take of the agency really influences which of those factors I think are most important for the agency. In my experience, because I've worked with a lot of the folks in these agencies and been in agencies, I tend to look at that individual actor level within the agency. What are these people doing? I think the scientists in the agencies have ways that they view these fish, ways that they view these populations, and certain right answers that they think are the right answers. And science itself has conflicts within it. It's not an internally consistent kind of field. You go to different labs that study these steelhead, and they'll tell you very different things. So when we were working on the San Joaquin reintroduction for the spring run Chinook, I thought, and folks in my lab thought, we really should not use fish from the Feather River, because those Feather River fish are mostly hatchery fish and are really, they've bred a lot in the fall run. They don't really look like spring run anymore. But 2 other labs both said, no, those fish are the best fish to use. We've been in hatcheries a lot, they're great fish to use. And ultimately that's what the agency decided, was to use these fish. And part of it is because that's what those people were saying. Part of it is because it was easy, those fish are available. So, the factors that you consider at any given point, you can start, like I said, at that individual level and build up. What are the scientists within the agency saying? I think there are kind of external factors to the agencies. What kind of political pressure are they getting from the outside? And they have a rule out for comment. They go to a meeting and they get yelled at for an hour, for 2 hours.
What kind of political pressure did you observe being applied to these agencies you studied?
Sure. And I didn't study that explicitly, certainly. I think that a good example of that, though, is within the Endangered Species Act, when you're reintroducing a population, this comes up in that reintroductions research that I did, you can list a species that you're reintroducing, or a population that you're reintroducing, as an experimental population, which is explicitly, it's a legal creation explicitly made to reduce political pressure on the agency when it's doing a reintroduction. So if you're reintroducing wolves, for example, people are going to get really upset if those wolves come out and they're going to eat their cattle. They're going to chase, their sheep, whatever it is. If they can't kill those wolves, if they can't protect their property, they get really upset about it, right? What the experimental designation, experimental population designation allows the agencies to do is to say, we're introducing this population, it's an experiment, and we're going to reduce the level of protection that this species gets in this area. So with those wolf reintroductions, they allow those wolves to be shot outside of the park. And the only reason they can do that is because of this kind of explicit allowance for it. And it tends to come in, again, I haven't done the actual research on this, but the people who have say that it comes in areas where they get a high degree of resistance to that reintroduction. And so the spring run reintroduction here of those fish in the San Joaquin River, that's an experimental population. Thanks for coming. Experimental population, and those fish, if they're taken in normal agricultural operations, during any activity that's legal under other state law or under other federal law, there's no liability associated with killing those fish, even though they're listed fish. And that's really because this is such a charged environment here. If you want to do that reintroduction, this gives the agency political cover to do it without people beating down the door. And they're already trying to strip the ESA away from those fish anyway. But. Any other questions?